Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome back to NPTEL online course on logistics and supply chain management. Today we will start discussion on sequencing and scheduling, right. So, in the last session we discussed about capacity planning and we discussed how we are supposed to plan our resources, right. We need to plan the capacity so that we can meet the requirements coming from the customer end in terms of demand, quantity, quality, whatever, right. So, now the very next thing is, once you are planning your capacity, obviously it is very important to define in what order, in what sequence you need to process all the jobs, right. You have different jobs in one project whenever you are producing product as well, right. So, in this session we will discuss about in what order sequence you should plan your jobs, right, and then we will see how we can schedule those jobs for different machines. If we have one machine, we have multiple jobs, how we can schedule that machine. If we have two machines, multiple jobs, how we can, and sequence is same, how we can schedule those multiple jobs on two machines, and then three machines, and then n number of machines. Obviously, jobs will be always higher, number of jobs will be higher, right. So, we have limited number of machines, 2, 3 or more than that. So, then we will see how optimally we can make this assignment, allocation of different jobs on different machines, so that the total cost can be minimized, right. So, first we will discuss about the sequencing rules and we will see what are different advantages and challenges when we are implementing the sequencing algorithm, and then we will talk about the scheduling, how we can schedule multiple jobs on two machines by using Johnson rule, and then that Johnson rule can be extended for 3 machines as well. And after that, if more number of machines are there, then we have special case of assignment problem, right, which we will be discussing in the further session. So, sequencing, as I told you, is order of processing a set of tasks, right, how we should plan all the tasks in particular sequence, and scheduling is sequencing as well as we will find out the time, right, how much time is required on one machine, how will move from one machine to other machine the same job, because that job requires processing on machine 1 as well, machine 2 as well, and then will go on machine 3 or maybe more than that, right. So, then we will find out how we can sequence those jobs, and then the time required for all those machines for those particular jobs. In the first part, we will talk about only sequencing these tasks over one workstation, right. So, these guidelines are used to determine the order in which the jobs or tasks should be processed to optimize the performance and efficiency. Obviously, this is the main objective, that the efficiency should be higher, right, and optimally we should use the resources. So, here the point is minimizing the total processing time, that is we will calculate in terms of flow time, right, and how we can reduce the delays. We should assign the order, decide the order in such a way there should be minimum waiting time throughout that channel, and then how in that way we will ensure the resource utilization. So, if we will talk about the sequencing rules, this is first in first out. Usually we are following this. If you are going to bank, if you are going to post office, if you are coming for exam, first in first out, right, evaluation, right. So, those things are there when we are using the this kind of situation, we are using first in first out algorithm, right. So, very obvious, as the jobs are arriving, A is the first, B, C, D, E. So this is the sequence. So I am believing A came first, then B, then C, then D and E. So this processing time is known for each job. This is the requirement, pre-requirement of defining the sequence, and then the due date is also given. Due date means when I need to deliver job A, maybe after 5 days, job B after 6 days, likewise, right. Now I am interested to find out the flow time and whatever is the delay using first in first out algorithm. So obviously our first job is A job, will be assigned on the very first day and will take 3 days. So obviously after 3 days this job will be over. On 4th day job B will come and the processing time required is 4 days. So total will be 7 days. On 8th day C job is available, time required is 2 days. So total flow time will be 9 days, it will be completed. And then D job will come, it requires 6 days and or whatever unit is, yes, it is 6 days. So then it will require 9 plus 6, 15 days. And the last E job requires 1 day. So total flow time, this will be the sum of all this flow time, 3 plus 7 plus 9 plus 15 plus 16, right. And then you can find out the average flow time that is required for each job is coming 10 days for when you are using first in first out algorithm, right. Now I want to find out the delay by using this particular algorithm. So job A we are delivering after 3 days, it was supposed to be after 5 days. So we are well on time. Job B we are delivering on 7th day, but it is supposed to be on 6th day. So 1 day delay is there. C we are delivering on 9th day and we are supposed to deliver on 7th day, 2 days delay is there. Job D we are delivering on 15 days, after 15 days and we are supposed to deliver on 9th day. So that is 6 days delay is there. Similarly for E, 14 days delay is there. So you can sum up the total delay and average delay per job is 4.6 days if you are using first in first out sequencing algorithm, right. Now we will go for the second algorithm, that is last in first out, and these are situation when we are processing the last one first. Let us say if you entered first in the lift, you will come out last in, from the lift, right. If you are going, you are submitting all the books, right, 10 students are submitting the books to the library. So there is stack, pile is there, so they will process the latest one first, then we will pick the second, third, fourth, and the book which came the first will be processed in the last, right. So there, this is also algorithm we are using for last in first out again. So then the job sequence will be reversed, E, D, C, B, A, and accordingly processing time is given. Now let us find out the flow time. 0th day I will process E job, requires 1 day, so total will be 1. So then after that 1 plus 6, because D requires 6 days, it will be 7. Then 7 plus C requires 2 days, it will be 9. So 9 plus 4, it will be 13. B will be delivered on 13th day, after 13 days, and then 13 plus 3, A will be delivered after 16 days. Again you can sum up all these flow time and you can see 9.2 days per job is the average flow time. Let us talk about the delay. Job E we are supposed to finish by 2 days, we finished in 1 day, no delay. Job D we are supposed to finish 9 days, we finished in 7 days, no delay. Job C 7 days should be, but we finished on 9th day, 2 days delay is there. Job B 6 days should be there, but we finished on 13th day, that means 7 days delay is there. Job A due date is 5, but we delivered on 16th day, 11th day days delay is there. So you can again find out the average delay is 4 days per job. The another sequencing rule is shortest processing time. Whosoever is the shortest processing time will be processed first. But the problem with this type of algorithm is, if anything is taking the longest time, that will be delayed for infinite time, right, you cannot decide. So that is the only job left out and then you will do that job, right. So, you are not taking care of the due date and all those things. So, that also sometimes is important. If let us say you have one job pending which requires 5 days processing time, and you need to deliver after maybe 6 days, and there is another job which requires processing of only 1 day, but you need to deliver after 15 days. But you are producing that process, you are processing 1 day job first because shortest processing time, even though you need to deliver that at the 15th day, right. So, that is the limitation of this shortest processing time. So, you can see as per that I have sequenced all these jobs. Again, due date is the data given, flow time again you can calculate. On 0th day 1 day is required, 1 plus 2 3, then 3 plus 3 days required for A job, then 6 plus 4 days required for B job, then 10 plus 6 days required for D job. So, in the end flow time you can sum up and you can see the average flow time is 7.2 days. Now, let us find out the delay. E job we finished on the first day, no delay because due date was 2 days, and then C we finished in 3 days, and due date was in 7 days, that is no delay, and then A we finished on 6th day and due date was 5 day, no 1 day delay, and then B job flow time is 10 and it is supposed to be finished by 6 days, 4 days delay, and then job D due date is 9, we finished on 16th day, 7 days delay is there, but still you see this shortest processing time when we are following compared to the last in first out and first in first out, the average delay is less, 2.4 days only, right. The another sequencing algorithm is longest processing time, just opposite of that. So, that means longest processing time will be processed first. This is how you have arranged this in the descending order. So, again flow time you can calculate, simple, 6 plus 0 plus 6, 6 plus 4 days required for B, 10 plus 3 days required for A, 13 plus 2 days required for C, and 15 plus 1 day required for E. And then due date you can compare with the flow time, there is no delay, here we are delivering after 4 days, here we are delivering after 5 days, 8 days delay, 14 day delay, and again you can see 6.8 days delay, average delay, longest processing time, taking probably the longest time, and average delay is very high for processing all these 5 jobs. The another rule you can opt for is sequencing rule, earliest due date. Whichever you need to deliver early, you can process that early, right. So, obviously then due date you will schedule, first 2 days you need to finish this. So, let us process this, then 5 days, 6 days, 7 days and 9 days. So, this is how you have sequenced all these, processing time will be given, and flow time again you can calculate, 0 plus 1 1, and then 1 plus 3 days required for A, 4 plus 4 days required for B, 8 plus 2 days required for C, and then 10 plus 6 days required for D, right. So, this is the total flow time, average you can find out. So, let us find out the delay. Job E, you are supposed to deliver after 2 days, you delivered within 1 day, perfectly on fine, and then A also within time limit, B you delayed by 2 days, you finished on 8th day and supposed to be finished on 6th day. C job again 3 days delay is there, D job again 7 days delay is there when you can compare 16 by 9. So, total average delay for all the jobs is 2.4 days when you are using earliest due date algorithm. The next algorithm is least slack. So, slack is the how you can find out the slack. Slack is the difference between the due date minus the processing time. So, the job which is having the minimum slack time you will process first, right. So, there will be very little time left over before the deadline. So, this least slack aims to complete those jobs first, right. So, we are considering the due date and we are considering the processing time. So that those required to be processed first, we will process first. So obviously you can find out this slack time for all these activities. Here I have calculated, and then the minimum slack time is remaining for job 5. So job 5 will be done first in the sequence. Then the next minimum is 5 and 5. So you can pick arbitrarily, either you can pick job 2 or you can pick job 4, because both are taking same time. So there is no point, right? So 2, 4, then 1 and 3. This is the sequence, and again you can find out the flow time, you can find out the average time, right? Simple least slack method. The next one is critical ratio. Now you are calculating the critical ratio by dividing the total remaining time until the deadline by the total remaining production line, time, right. So critical ratio is calculated time remaining until due date and processing time required. Again the job which is having minimum critical ratio will be processed first, right. So this due date is given, processing time is given, and you can calculate CR and the critical ratio for job A 2, for job B 5, 2.51. So you can see you should process job D and job A and then job C and then job B as per the critical ratio DACB. So this is, you can see the final sequence is this, and then you can obviously find out the flow time like we did in all those previous examples, and then you can find out the delay. So actually you can compare all these algorithms, who is taking the maximum time, the flow time, and then the delay, where is the maximum delay per job, right. This is easily you can find out. So what are the advantages if we talk about sequencing? Obviously we can avoid the bottlenecks, wherever bottlenecks are there, which is limiting your production. So you can address those bottlenecks, those checkpoints will be there. Adaptable planning, because when you are talking about using critical ratio method, right, or the earliest due date, when you are considering due date in your algorithm, that means that is dynamic programming. After every day this will change, the ratio will change, right. So every day you can plan your resources in that way, and you can sequence the jobs. So possibility to choose a selection of standard rules. So there will be no conflict. So because we are using any of this algorithm, so if I know I am first in the sequence, I will be processed first. If I am last in the sequence, I will be processed last. That doesn't matter whether I am in emergency or urgency, whatever is the situation, right. So because they are following first come first serve algorithm, so that will be done. So lean production will be there, because we have standardized these algorithms. So obviously we can avoid the wastage of taking the decision, making the adjustments, all those things. Customer can adapt process sequence to their unique individual requirements, right, and this will enable us to plan and process and understand everything, and then we can process in that way. And we are also ready with the programming, what if something will go wrong, so what will be the next in the sequence, right. So that also we can plan. Obviously some challenges are there, because we are saying that it is dynamic, so we are changing very frequently. So when yesterday you planned something, so today because also critical ratio changed, so now you are planning some other sequence. So that disruption is very difficult to standardize the process. So that can happen if your adaptable kind of algorithm is there. Limited availability of resources such as machines, labor and material. And then see, if you are saying that first the sequence is A, B, C, these jobs will be done, right. But after A, we are struggling to get the raw material for processing B. How will do that? But as per our algorithm, we should process B, right. So that means that sequence there is problem, so we are not considering the resources. So sometimes we need to change that also, which is causing delay, right. So optimality is also in question in that way. What if we have large scale operations? Then every day 1000 jobs and you are shuffling here and there will be very confusing, right. Balancing different prioritization criteria, because due dates, job importance, customer requirements can lead to conflicts, right? So if you are considering due dates, so obviously importance is not only important when you are delivering the product, right? Sometimes importance may be if I am doing job A and I am doing job B, maybe I am focusing job A because I need to deliver it early, but the job B due date is later, but the customer which is getting benefit out of job B is very frequent, loyal, regular customer, and the revenue I am generating out of that customer is, so that I am not considering those things. So these are not, we are considering in the this sequence. Sequencing job with minimal setup or change over time, that is also a problem. If so frequently you are changing jobs from one station to other station, this is problem, right? And then obviously we can use some softwares for sequencing and scheduling, right? But yes, those lack of integration with other system can pose challenges in implementing your optimal sequencing, right? So second part of this session is scheduling, which is again we will define the sequence where we have multiple jobs, and this time we will be having more than one machine, right? Earlier we were thinking only one workstation is there, how we will process A, B, C, D on that workstation. Now we will be having at least two machines, and again multiple jobs will be there. So again we have some computerized system, software, you can put any algorithm and then you can do that. Initially we will do this by using your Johnson rule, right? So the point here is what we are doing, we are allocating the start time, we are allocating the finish time depending upon whatever is the processing time required to perform that job, right? And then using that Johnson algorithm we will be finding the sequence. So we will do one or two numericals, we will see how we can do on single machine. See, these jobs are there, n number of jobs can be there, and we have two machines, and processing time for each job on machine 1 and then each job on machine 2 will be given, right? Here we are assuming that all will follow the same sequence. Job A is going first on machine A or machine B, whatever, but it will be processed on both the machines, right? So this is how we the problem structure is, and this is the algorithm. You can just go through, and some conditions are there that time for each job should be consistent and should be known. Time for each job on machine 1, machine 2, machine 3. How many machines are there? So that time should be known. Job time must be mutually exclusive of the job sequence. All job must be processed in first work center before going through the second work center. First machine, then second, then third. All jobs are equally prioritized. This is the assumption that all jobs are equally prioritized, and then we will apply the Johnson rule to sequence. So you can just go through these steps. I will use these steps to to solve this problem, and you will come to know how we can solve the problem using Johnson rule. Now Johnson rule, first step says that you need to list the time required to perform that job on machine 1 and then machine 2. Here we have listed the time on machine 1 and machine 2, right, for job A, B, C, D, E. So we have 5 jobs. Now algorithm says that find out the minimum time required to complete any job on any machine. What is the minimum value? I believe the minimum value here is 1.5, right? You mark that job, this is job B. If this minimum time is on machine 1, put that job first in the sequence. If it is on machine 2, put that job last in the sequence. If this is the sequence, we have 5 jobs to perform. So because minimum time is on machine 2, so we will put job B last in the sequence. I am repeating again. So once it is placed, you will strike off. Now this machine is not available. Now again I am repeating, you just imagine we have only 4 jobs. We will find out whosoever is having the minimum processing time. I think now 2.2 is the minimum value. If this minimum value is on machine 1, place that job first in the sequence. If it is on machine 2, place then job last in the sequence. Last in the sequence means Now last is this block only, because last block is already occupied. If first is occupied, then first will be this one, right. So here C will be placed first in the sequence because it is on machine 1. Then we have 3 jobs. Now the minimum time I believe is 2.8, which is for E. Machine 2 will place last in the sequence. Now E is also gone. Minimum time is 3.2, that is on machine 1, job A, and obviously only left out is this. So C, A, D, E, B. So you can see these all steps are there given C, A, D, E, B, right. So this is how we can sequence using Johnson rule. So this rule can be replicated for more than 2 machines, but yes, I will find out, because here it is not given. I will find out how we can find out the time required on each machine, and then we can allocate this, right. So I need this table. Okay, here only I will do that. Let us say this is for machine 1, right. So machine 1, first job will be your C. So C is coming on 0th day, and how many days are required? Let us say I am saying that this time is in days. How many days are required for job C? 2.2 days are required. So 2.2 days it will be available. Then next job in the sequence is A. How many days required for job A on machine 1? 3.2. So that means if I will add 3.2, so this will be 5.4. Then next job in the sequence is D. How many days it is D requires? 5.8. So that means total will be, if I will add 5.8 into 5.4, it will be 11.2. The next job in the sequence will be E. So E requires how many days? 3.1. So if I will add this 3.1, obviously 14.3. Next job is, last job is B. How many days it requires on machine 1? 4.7. If I will add that, so total will be 22 days. So all these 5 jobs will take 22 days on machine 1. Let us now plan for machine 2. Now see, because sequence is C job will be processed first on machine 1. So that means up to this point machine 2 will be idle, because there is no job to process, because right now the first job C we are processing on machine 1. So for 2.2 days initially the job machine 2 will be idle, right. So after that C will come. Now C will take how many days? 5 days. So that means 2.2 plus 5, so that means how many days it will take? It will take 7.2 days. So 7.2 days will be somewhere here after 5.4. I am just randomly I am just referring this, but yes, because this is 5.4 timeline, I am writing here somewhere 7.2. So C took 5 days, 7.2. Now after that A is available. A is available on 5.4 day. So can we process it straight away? Yes, we can process, because we are on 7.2 days and A job is available on 5.4 day. So A job will take 4.2 days on machine 2. So that will make your 11.4. So 11.4 will be little here, because 11.2 is here. So 11.4. Now next job is D. Whether D job is available at 11.4? Yes, it is available, because we are finishing D on machine 1 at 11.2. So we can straightway start job D on machine 2. Now job D requires 4 days. So that means 4 days. So when we will finish it? We will finish it on somewhere here 15.4 days. So 15.4 days, whether the next job is available, next job is E. Yes, E is available on 14.3 days. We can straightway start job E, right. How many days it requires on machine 2? 2.8 days. If I will add those 2.8 days, it will be total 18.3 18.2 should be here, means let us say 22 is here. So, 18.2, right. Now, next job is obviously the remaining one is B. Whether B job is available at 18.2? No, B job is available at 22 days, after 22 days. That means these many days I need to wait. So, again machine 2 will be idle for how many days? 3.8 days. That will make 3.8 plus 18.2 will make 22. So, we will come here at 22. So, this is delay, means not delay, idle time for machine 2, because still the processing for that particular job which is B, the processing has not finished on machine 1. So, now on 22nd day, after 22nd day we can start your job B, which requires 1.5 days. So, finally, we will finish this job B on 23.5, right. So, if I will say total time required, it will be 23.5 days, because we are starting on 0th day here on machine 1, we are ending on machine 2 at 23.5. Let us say the idle time for machine 1 and idle time for machine 2. Machine 1 is starting straight away on 0th day, but yes, after 22 days, because last operation we are doing on 22 days. So, after that it will be idle if we are not processing anything else. So, 23.5 minus 22, so that means 1.5 days idle time for machine 1. Machine 2 idle time, initially 0 to 2.2 machine 2 did not work, because we were waiting for first job to be finished on machine 1, and then in between we waited for this 3.8 time period. So, total is 6 days machine 2 was idle for total 6 days. This is how we can sequence the jobs and we can find out how much we are utilizing each machine. So, I think this is clear. Okay. Now, we will expand this algorithm for 3 machines. You can just go through this algorithm. I will just take this example. Now, to find out initially the sequence, we will convert this 3 column matrix into 2. How? A plus B, B plus C. So, I will add, and again I will consider those 2 columns as 2 machines, right. So, once I will add, this is the new processing time, and again the algorithm is same, that find out the minimum time. Now, minimum time is 8, I think 8, and it is for 2 jobs. So, for job 1 and job 4. So, when it is for machine 1, place that in first in the sequence. So, 1 is gone, 4 is gone. Next minimum is, I think next minimum is 9, yes, and that is on machine 1. So, put that next in the sequence. This is also gone. Next minimum is, I think 11, that is on machine 1. So, that means 3. So, straight away we got this sequence 1, 4, 5, 3, 2, right. Now, again this total is there. Now, we need to find out the time, right. So, again we need to draw that. We can draw for all these 3 machines. So, this sequence is 1, 4, 5, 3, 2. Right. So, let us draw this. Now, for machine 1. So, machine 1 is arriving at job 1 is arriving at machine 1, and it on the very first day it requires 4 days. So, this is machine 1, so requires 4 days. Then next is 4th, requires 6 days. So, here it will be 10 days. So, this is machine job 4. Then is 5th, requires 3 days. So, somewhere here 13, and this is job number 5. And then 3 requires 8 days. So, obviously 8 days somewhere here 21, and this is job 3. And then we have job 2, last one requires 9 days on machine 1, and you can just add those 9 days and it will be somewhere here, and this is job 2. So, this is done all the jobs for machine 1. Let us now go for machine 2. Similarly, we will go for machine 3. Now, first 4 days machine 2 will be idle, because the first job we are processing on machine 1. Now job 1 will come after 4th day, and how many days it requires for processing on machine 2? 4 days. So, 4 days, that means 8 somewhere here. Now, next job is available after 10 days, which is 4. This 4 is available after 10 days, right? So, that means we cannot start straight away. This is again the idle time. So, we will start 4th on the 10th day. So, you need to note down that here 2 days delay is there. So, initially for machine 2, 4 days delay, then 2 days delay. So, you keep on adding, right? So, here the space is little less, so that is why I am writing list. Otherwise, you can draw machines like this also, it is better. So, wherever you are assigning any value, you can write 2 days, and if you are not assigning, you can write this is 1 day delay, right. So, next is 4th job, and we have 4th job here requires 2 days. So, we will be finishing on 12th day only. Now, you see again we need to wait for 1 day, because your job 5 is not available. So, we are here also we are waiting. Now, 5th job will require 6 days on machine 2, that will make I think here 13 plus 6 19, right. So, 19 again job 3 is not available for next 2 days, right. So, then we will start 22nd, we will start the 3rd job, which will require 3 days. So, it will take up to 24, and then whether we have the last job? No, the last job is available after 30 days. So, that means again we have a delay idle time for machine 2 for 6 days, right. And then on 30th day it will be reaching on machine 2, and it requires job 2 requires your 5 days. So, 35 days it will be over your machine 2. So, you see this is the idle time for machine 2. Similarly, you can extend this to machine 3, and I will just complete the first one. See, up to first 8 days your machine 3 will be idle, because after 8 days only your job 1 will be coming for machine 3. So, initial delay of 8 days, and then how many days required? 6 days. So, 14 will be somewhere here. So, 14 you will be processing first job. So, after 14 your job 4 is available on 12 days. So, straight away you can start, because you are on the 14th day. So, there is no delay. You find out job 4 how many days are required, 8 days are required. You can keep on adding 22. Here also you can find the waiting time, and this is how you can find out the idle time for each machine, and then waiting time for each machine, right. So, this is how this Johnson rule can be extended, and you can see I have calculated this for all these machines. Different methods are there. You can go for this table format, you can just draw the lines, you can just draw the boxes, you can find out different way you can use that. Now, what if we will be having more than your 3 number of machines? So, then we have next session the assignment problem, where we will see we will be having one matrix, where we will be listing job 1, job 2, 3, 4, 5 n number of jobs, and machine 1, 2, 3 m number of machines. So, cost of assigning job 1 on machine 1, cost of assigning job 2 on machine 2, machine 1, all these costs will be given, and we will solve using assignment problem how we can assign this, so that the total cost can be minimized. We have separate session for that. So, For this, this is all about the sequencing and scheduling. So, these are the references and you can practice some more numericals on that. So, that is all for this session. Thank you very much.